Good day, everyone. Today we are now in the part 3 of our discussion, but this is quite similar to part 2 and it does not require a lot of computation. So all we have to do here is to analyze carefully the theorems that we'll be discussing later. Okay, so for the continuation, we have the theorem number 11. Now, the theorem number 11 states that if a is any real number except 0, then the limit of 1 over x as x approaches a is equal to 1 over a. Now, this is quite easy because we already discussed about the limit of the quotient of two functions, right? So, in this case, we can consider 1 over x as the quotient of two functions, quotient of a constant function and identity function. So by applying the limit theorem for quotient of two functions, so we can have the limit of the numerator constant, which is constant 1, over the limit of the denominator as x approaches a. So this is identity function. We can just simply substitute a to the variable x. That's why we have 1 over a. So that is, we use the limit of the quotient of two functions. But actually, we can simply substitute the value of our x, which is a, in the variable. That's why we have 1 over a. For the number 12, if a is positive and n is a positive integer, or if a is less than or equal to 0 and n is an odd positive integer, then this one is true. Now, we also discussed this one, but without condition. Now, in this number 12 theorem, we just make it clear by adding some conditions if a is negative and if a is positive. Now, it is clearly discussed here that if a is positive, then also the index must follow that n must be positive even, okay? Because if a is negative, in this case, if a is negative and we have the index which is also even and positive, then we can have an imaginary number. However, if a is negative, this is still possible if n is odd positive integer. Okay, so for example, this is, for example, the square root of 16, for example, right? It exists because a here is positive. So we can write the square root of 4 squared, right? And what's the answer applying the n-truth property? So we have the index 2 and the exponent 2. So the answer is 4. So in the case if n is if a is negative or 0, for example, the cube root of negative 27. This is possible because the index is odd. We can have, by using this one, we can have an a which is negative. Now take note that the cube root of negative 27 can be written as the cube root of negative 3 raised to 3. So the answer is negative 3. Okay, so it's possible. Now for the next theorem, this theorem states that if f of x is equal to L as x approaches a, so if and only if the limit of f of x minus L as x approaches a is equal to 0. Now, this is biconditional. So if this is true, then this is true. And if baliktarin natin, if this is true, then this condition must also be true. Now, take note that the limit of f of x minus L, we can apply the limit of the sum and difference, right? So we can have limit of f of x as x approaches a minus the limit of L as x approaches a. Now, is this really equal to 0? So that's the question. Can we equate that one to 0? Yes, because by assumption, this is what? What is this? That is your limit of f of x as x approaches a is equal to L. Then the limit of L, where L is constant, right? So L minus L is equal to 0. Okay, for number 14, limit of f of x is equal to L if and only if this one is true. Meaning to say, take note, and since biconditional pa rin siya, limit of t plus a, okay, as t approaches 0 is equal to L. Because take note, if we are going to evaluate this expression, limit of t plus a, as t approaches to 0, so we can simply substitute 0 in this variable t, so we can have a function of f of a, right? Okay, if t is 0, okay, t 0, we can have a function of a. Now take note, since we have a function as x approaches a, so we might have a function of a also, which is equal to L. Okay, so take note of that. Now, number 15, limit of f of x is equal to L1 as x approaches a, and limit of f of x is equal to L sub 2 as x approaches a, then L sub 1 minus L sub 2. In other words, this means that if we have a function and it has a limit of L1, okay, and also the same function, then the limit is L2. And since f of x is just the same with this f of x, therefore, L1 must be equal to L sub 2. What does this mean? This means that for a function to exist, for the limit of a function to exist, okay, the limit of that function must only be equal to what? There's only one limit of that function. Now, later on, we will be discussing about one-sided limits, and later you will know um, that if one side or the left hand side um, is different, the limit of the left hand side is different from the limit of from the right hand side, then we can simply say that the limit does not exist. That's why it also like this, that there is only one limit for a function, for the limit of a function to exist. Okay. Okay, so for next. Okay, so we have done with the part 1 and part 2 and part 3. So this time I want you to answer all the exercises here. This can help you to understand more on the concept. And since it's calculus, it needs a lot of hard work and practice. So all you have to do is to practice this one as many as you can. Then if you have some questions or concerns related to these exercises or to the lessons that we had, you can email me directly or you can comment your question, suggestion in the comment section. Okay? Or if you have answers in these exercises but you are not sure, you can still message your question, or you can message to me with your question or with clarification. Okay, so thank you so much and God bless. Hope you like this video and do not forget to share the learning that you got from this video. Once again, thank you very much and God bless.